All right, so chapter 3 is all about special angles, and we're going to continue with proofs, but they're not. In my opinion, chapter 3's proofs are like one of the easier ones. I love chapter 3. It's all about special angles and like lines, parallel lines, that kind of stuff. Standardized tests love this stuff. I guarantee if you take a PSAT or an SAT, you would see something on the material we're going to cover today or tomorrow. Like I would almost pay you money if you didn't see it. Okay, there's a lot of you, so I won't, and I'm a teacher, so I'm broke, so I won't. But I would almost guarantee it's going to happen. Okay. All right. So parallel versus skew is the first type of lines we're going to talk about. Parallel lines are coplanar lines that do not intersect, and skew lines are non-coplanar lines that are neither parallel nor intersecting. So if they don't intersect and are coplanar, they're parallel. If they don't intersect and are non-coplanar, they're skew. Parallel planes are planes that do not intersect. So if you think about a box, the top and the bottom, the front and the back, the left and the right would all be parallel planes. Do you remember how to name a plane? 3 letters, right? At least 3 letters. Okay, so I could give 4, but at least 3 letters. So what could I call the top? Say again? AGH. Okay, is an example of what you could call the top. A lot of times your book will actually use all 4 letters. So I could call the top A, B, H, G, or I could call the top A, G, H, or A, B, H, okay? Any of those options. So if I asked you for a plane that is parallel to A, B, H, G, what would you give me? E, F, D, C, right? Or the bottom. D, F, E, E, C, D, D, F, E, any of those options, okay, would be parallel. The symbol for parallel is like this. So you could write that as A, B, H, G is parallel to E, F, D, C. And again, when you use letters, you're implying planes. Okay. When I'm using 3 or more letters. If I wanted to say lines, like I could say that AG is parallel to BH. Now I'm talking about the segments, right? Okay, parallel postulate and perpendicular postulate. So the parallel postulate, which has a name, okay, so it's not a number, it's a name you can use, says if there's a line and a point not on the line, then there is exactly one line through that point that is parallel to the given line. And I'll show you what that looks like in a second. And the perpendicular postulate says if there's a line and a point not on the line, then there is exactly one line through that point perpendicular to the given line. A transversal is a line that intersects 2 or more coplanar lines in different points. A line that intersects 2 or more coplanar lines in different points. So there's 3 lines on this slide. There's line M, line J, and line K, right? Which of those 3 is the transversal? Line M. Line M is the only one that intersects 2. You with me? You see that? Yes? So M would be the transversal here. It intersects 2 or more. I could have added lines to here. 2 or more coplanar lines at different points. So they can't crisscross. It can't be like this, right? now line M, if I took away this, would not be coplanar because those are the same point and not different points. That's what that means. Okay, so then you've got two different kinds of angles when you've got a transversal that intersects two lines, interior and exterior. So the easiest way to see this is if you were to draw a little box connecting the two lines, not your transversal but the other two, anything inside that box is interior. So my interior angles would be angle 3, angle 4, angle 5, and angle 6. And then anything outside that box are exterior. Angle 1, angle 2, angle 7, and angle 8. So interior is in between the two lines, exterior is outside. Okay, the two lines don't always have to be running like left to right. So in this time, if this was A, this was B, and this was C, which one is my transversal? C. Which angles are interior? 2, 3, 6, and 7 exterior?
1, 5, or 8.
Good. Questions on that? Anybody still copying? For now.
You said that if you add another line, it's not.
If I add, no, if I were to crisscross these lines. So if I had a line like this, and I did this, and I did this, right? This line, let's say this is line A. A is still intersecting two or more coplanar lines. The problem is it's intersecting them at the same point. And by definition, it has to be at different points. Yep, that's all it means. There's got to be some sort of separation there. So if it had a third line, there's two groupings of interior and two groupings of exterior. So it depends on which lines I'm talking about. Does that make sense? So it would say like which angles are interior for A and B, and you would know to group those together. Okay, so the reason why you need to know interior and exterior because there are 4 special angles going on in these lines. Okay, the first is called alternate interior. Alternate meaning on opposite sides, God bless you, on opposite sides of the transversal, interior being in between the two lines. So alternate interior are non-adjacent, they can't be next to each other, on opposite sides of the transversal. And then alternate exterior are 2 exterior angles, so they got to be outside the two lines, opposite sides of the transversal. So where are my interior angles? What would be my interior angle numbers? Nicholas? 3, 4, 5, and 6. So if I started with 3, okay, so 3 is here. What would be not next to it, but on the opposite side of the transversal? Angle 6. So 3 and 6 are alternate interior, which means 4 and what? 5 are alternate interior. And then exterior is now outside those lines. So alternate exterior would be 1 and, good, 8 and 2 and 7. Right, if we go back to these, do these look like they're parallel? No. Okay. There's 4 types of special angles and you're going to use these a lot. Okay, same side interior says that they are both interior and they're on the same side of the transversal. Corresponding says 2 angles in corresponding positions relative to the 2 lines. So I'll give you a little bit of visual on that one. All right, so same side interior, which you'll see a lot shortened as SSINT, okay? Same side interior. So like if you're going to use exterior, interior, you can do EXT, INT, that kind of stuff. Interior angles on the same side of the transversal. So interior angle that would be on the same side of transversals would be what? 3 and 5, and 4 and 6. And then corresponding. So the easiest way, in my opinion, to look at corresponding is make a little box around where your lines intersect. And then the same spot in correlation to those lines, meaning top left, top right, bottom left, bottom right. So what's in the top left of my top box? Angle 1. And angle 1 would be corresponding to the angle that's in the top left of my bottom box, which would be what? Angle 5. How about angle 2? Angle 6. How about angle 3? Angle 7 and angle 4 and angle 8. Okay, so if it's hard to see, make yourself a little box, and it's top left corner, top right corner, bottom left, bottom right. So if I gave you this diagram, there are now 6 special angles you could tell me about. The 4 we just talked about, alternate interior, alternate exterior, same side interior, and corresponding. But what other special angle relationships are going on in this picture? Megan? Vertical angles like 2 and 3, 1 and 4, 5 and 8, 6 and 7. What else? Alejandro. Linear pair, 1 and 2, 2 and 4, 4 and 3, 3 and 1 are all linear pairs, right? And 5 and 6, 6 and 8, 8 and 7, and 7 and 5. So you've got 6 special angle relationship pairs going on in these diagrams. Questions so far? All right, so this was false. Okay, B, skew lines are not coplanar. True. They're not coplanar and not intersecting. C, if 2 lines are coplanar, then they are parallel. False. Okay, these 2 lines are coplanar, but they're not parallel. 2 intersecting lines are coplanar, but they're not parallel. And D says if 2 lines are parallel, then exactly one plane contains them. So I could really delve into that and compare it to if I had 2 lines that are parallel, right? We said that there would be 2 points on this line and there could be 1 point on this line. And what did we say is true about any 3 non-collinear points? Exactly one plane. Okay, so if you go back to your postulates, you could carry that over. All right, example 2, name the given angles. So again, I'll give you a minute or 2 to work on it, and then we'll go over it. All right, so who can give me a pair of alternate interior angles? Chris. Angle 2 and angle, say that again. They have to be non-adjacent. So what's on the opposite side of that line but not adjacent? If 2's here, 7, right? Opposite side of that line, but not adjacent. So 2 and 7, and then there's one more pair. Omar. 6 and 3. Good. So 6 and 7. Good. 2 and 7, 6 and 3. Okay, how about same side interior? Leah. Angle 6 and angle 7. And angle 2 and angle 3. And then corresponding. And corresponding, there's 4 pairs, right? Claudia? Angle 1 and angle 3. Emily, you want to give me one? Angle 2 and angle 4. Jessica? Angle 5 and angle 7. Allison? Angle 6 and angle 8. Good job. Okay, questions? So again, today's a lot of vocab. You want to be able to identify these. You want to be able to name them. Alternate interior, alternate exterior, same side interior, and same side, and corresponding. You want to be able to identify the difference between parallel and skew. Okay, and then tomorrow we're going to build on this a little bit more. We're going to learn about what happens if those lines are parallel.